Hey guys, today we're talking about the universe and everything that is included inside of it, space and everything inside. So we've already talked a little bit about galaxies. Galaxy is a cluster of stars, gas, and dust that are held together by gravity. There are more types of galaxies, more numbers of galaxies than we can even count. There are three main types though, so you need to know about irregular, elliptical, and spiral. In an irregular galaxy, kind of makes sense to what the name is. They don't have a regular shape, and so we call them irregular galaxies, not really a definable shape that we can describe. These galaxies contain young stars, a lot of dust, a lot of gas. An elliptical galaxy looks like a flattened ball, like if you could imagine a Nerf ball and you've squished it. You can see the shape right here. It looks like somebody has taken a round ball and kind of flattened it. That is an elliptical galaxy. They have billions of stars, but they're kind of tightly packed together. There's not a lot of gas and dust in between the stars. So as a result, most of the stars in an elliptical galaxy are very old, near the end of their lifespan. There's not a lot of material for new stars to form in an elliptical galaxy. Spiral galaxies, these consist of, you could describe it as a flat rotating disk, stars, gas, and dust, with a central concentration of stars. So you can see right here in the middle. And this is what we call the bulge. And these stars out here are more spread out. This is what we call the halo. These types of galaxies contain middle-aged stars. Our Milky Way galaxy is where we live, and it has been classified as a type of spiral galaxy, which is what we call a barred spiral galaxy. And the reason they call it that is because it has these arms. It's a little bit different from the other one if you look up here. These are a little bit more smoother, and a barred spiral has these arms. Kind of reminds me almost of like maybe a starfish. And our solar system is at the edge. A lot of people think it's common, well, we must be at the center of our galaxy. Actually, we are not. Our solar system, we are out on one of the edges of these arms, and that's an important detail to know. We are not here in the middle. We are out on one of the edges of one of the arms. Now, stars all start off in a nebula, but there's two different kinds. There's one at the beginning of a star's life, and there's one at the end of a star's life. So you need to know the difference between the two. A stellar nebula is sort of like a star nursery, and that is where all the material is that stars begin with, and it's just basically a big collection of gas and dust. A planetary nebula is at the end of a star's life. It's run out of fuel. It's burning off its outer layers. They're two completely different things. Stars are hydrogen gas, and that is their main source of fuel. So they form helium through a process known as nuclear fusion. And again, our old friend gravity is what's responsible for even beginning a star's life to even form in a stellar nebula. Stars release enormous amounts of energy, and that is what causes their temperature and their glow. And of course, they're not all the same size. They don't all have the same temperature, but it is all held together by gravity. What we know about stars is they have a very large amount of gas in a relatively small volume, so a relatively small amount of space. A stellar nebula is a large amount of gas and dust spread out in an immense volume. And remember, a stellar nebula is where stars begin. what happens is in a stellar nebula, eventually, if you look back here, eventually what starts to happen is this gas and dust and all these little particles, eventually you get some close enough together that gravity starts to attract the particles. And so over time, as gravity starts to pull some of this gas and dust together, they start to begin to form a cloud that we call a protostar. It's like a baby star. You can think of it as like a prototype, a pre-star. It's not until the process of nuclear fusion begins that we actually call it a star. So what can happen is these protostars, this beginning of a star, sometimes that's all a star ever does. It keeps its whole life and it never gets hot enough. If nuclear fusion doesn't begin, we don't officially call it a star. So sometimes the gas and the dust comes together, but it doesn't ever get hot enough, and so it spends its whole life as a protostar. If it gets hot enough that nuclear fusion begins, then we officially call it a star. Before they can decide what type of star it is, the scientists first have to figure out how big it is, because the mass will determine how they classify it. Our sun is a medium star. There's stars that are smaller, there's stars that are a whole lot bigger. And the lifetime of our star is somewhere around 10 billion years. Stars that are about the same mass as the sun, these are what we call main sequence stars. They're pretty average as far as comparing them to other stars in the universe. The more mass the star has, the shorter their lives are. You can think about it as, kind of their 15 minutes of fame goes through faster. They use up their fuel faster. So their lives are much shorter. The smaller stars, their fuel lasts them longer, so they can go for about 200 billion years. All right, so what we have, the stars form in a stellar nebula from collapsing clouds of gas and dust. Then we call it a protostar when it starts to condense together. After it gets hot enough to be called a star, what we call it next depends on the mass and how much of this gas and dust is together. To determine the mass is what tells us which direction the star goes next. When a star runs out of fuel, then there's several things that happen at the end of its life. All right, main sequence stars. That's the stage where most stars spend the majority of their life. When they start to run out of fuel, the first thing we call them is red giants. They run out of fuel, their outer layers start to expand because they're cooling. And we know that when things cool, they tend to expand. So it sounds backwards, but that's exactly what happens. They're running out of fuel and they're expanding. Eventually, these outer parts here just kind of drift off into space. What's left behind is just the core, and we call that a white dwarf. I always think about like the leftover part of, like, maybe if you have a fire and you're down to like one piece of charcoal or wood and it's just one little white hot piece left, that's what we call a white dwarf. That's after all the outer layers have burned off. When the white dwarf eventually runs out of energy and cools, then we call it a black dwarf. And that's basically a leftover, burnt out cinder. It's almost like space junk. Now, the more massive stars are, when they run out of fuel, we refer to them as supergiants. So you can think of it, the more massive the stars are, we call them massive stars. When they start to run out of fuel, we call them red supergiants. When they run out of fuel, it's not a quiet spectacle. They can suddenly explode. And when that happens, we call it a supernova. after the star explodes, some of the material is left behind, and this may become part of a planetary nebula. What isn't just sort of floating around, the core, what's left, will compress and form a neutron star. These neutron stars are even smaller and more dense than white dwarfs. The most massive stars may have more than 40 times the mass of the sun. One might have more than 5 times the mass of the sun left even after it becomes a supernova. So we're talking about enormous stars. The gravity of this is so strong because all this mass that sometimes the gas is pulled inward and packs into smaller and smaller space, and that is what we call a black hole. So these really big massive stars, not all the time, but lots of times after they become a supernova, then they might become a black hole, but it doesn't happen every time. All right, guys, thanks so much. Work on your notes and get all of your graphic organizers done so that you understand the life cycle of the stars and what happens when they run out of fuel.